So, guys, as you know, we are doing hypothesis testing, and we here use null hypothesis as 0 and alternative hypothesis H1, right? We discussed this thing in binomial distribution, and same thing, same concept we have to apply in case of Poisson distribution. Obviously, Poisson distribution has some other parameters, like its parameter is this. Here it's given gamma, or in some books it may be alpha. So we will use this Poisson distribution testing in exercise 14C. So we start from this question number 1. So as you can see, let X have distribution Poisson gamma. This is the parameter of Poisson distribution, and let X be the number of occurrences of the events in the given time interval. By finding the appropriate p-value, carry out the following test. So as you can see, this null hypothesis, this parameter gamma equals to 7.2. Alternative hypothesis, this gamma is less than 7.2, and X equals to 5, and using a 5% significance level. Okay, it means what we have to do. We have this is Poisson distribution, and its parameter is 7.2. We have to find out the probability for X okay, less than. This is for less than H1 alternative hypothesis. We are looking for the less than. Okay, so less than, and this X equals to 5. So that's also 5. Okay, so here we will use the calculator to find out its probability. So as you can see on your screen, I'm going to use calculator statics menu, open menu, statics is there, and I will hit execute, and yeah, this will be on your screen. F5 for distribution, then hit F6, and Poisson, this is Poisson distribution, PCD, hit variable, yes, variable, yeah. Here my calculator has a little bit more advanced feature because it's more advanced. So yes, you can use 99 for the lower upper 5. Okay, upper 5, and this is, I think it's a 7.5. 7.2, sorry, 7.2. 7.2, execute. Okay, so this is the probability. The p-value is 0.27589. So we can write 0.2759. Okay, okay, so we will write this value 0.2759. So as you can see, I have written this p-value over here, and your calculator Casio, what model you are using. So no problem there. You need to simply write the X values and parameter that will give you answer. Now, our significance value is 0.2759. And what is the significance level? Significance level is 5%, right? Here I'm writing significance level means alpha is 5%. 5% convert into probability 5/100, that is 0.05, right? As you can see, this p-value, right? This 0.2759 is greater than 0.05. Okay, means p-value is greater than alpha, significance level. So it means we sell accept, we shall accept null hypothesis. I think it will be clear for you. Would have been clear. Question number 1b, you can see that null hypothesis parameter is 5.9. We are looking for greater than 5.9, and here x equals to 10, and significance level is 5%. So we have this is Poisson distribution. Parameter is 5.9. We have to find out the probability for this is Poisson distribution, or simply write over here x is greater than, because greater than and is equal to 10, right? So greater than is equal to 10 means the probability of x greater than equal to 10 means if you use your calculator, so you will have to do 1 minus probability of x less than equals to 9, because your calculator does not have the option of lower and upper, right? So you will be able to find out the probability until 9, and then 1 minus probability until 9, you will get the answer. But the calculator which I am using, that is having lower and upper option, so I can get direct answer this greater than equals to 10, because here the upper lower bound is 10, lower value is 10, because we have 10 more than 10, we have to find out probability. So I will use my calculator, and this gives me a Poisson distribution here. Yes, lower is 10, right? Lower is 10. Upper, okay. Poisson distribution, and okay, parameter is 5.9. 5.9. Okay, execute, and then this. So this is 0.0772. Okay, 0.0772. This is the, okay. We will note down this one. So you can see that this is the 0.0772, and significance level again here. We have 5%, 5% means 0.05. As we can see, this 0.07 is greater than 0.05. So this is significance level. A p-value is greater than significance level. It means we shall accept null hypothesis. Okay. So guys, if you see in question number 2, during the previous year, the school bus has been late on average 1.8 times per week. Means in 1 week, what is the late average? 1.8. A new route has been introduced for the new year, and in the first 2 weeks, the bus was late just twice. Okay. Determine whether this sufficient evidence. This is sufficient at 5% significance level that average has been. Okay. So as you can see this one, what is the average? 1.8 per week. Okay. And this we have to find out for 2 weeks, right? That was just late, just twice, right? So determine whether this sufficient evidence at this one. Okay. So now we will have new Poisson distribution, right? New Poisson distribution. So we are looking this distribution for 2 weeks. Okay, 1 week, what is average? 1.8. So for 2 weeks, 2 times 1.8. So it will be 3.6. Okay, this will be new mean will be 3.6. Okay, and so what is the null hypothesis will be, right? So null hypothesis will be, suppose we are using this gamma over here. Average is 3.6. What is saying that this one? Then alternative hypothesis H1 will be lambda, right? So less than, okay, we will look for the less than, because as per this one only 1.8 average, so we are looking for less than 3.6. And now determine whether they, okay, then for the new year, first 2 weeks the bus was late just twice, okay, so we have to look for the just twice means only 2 times. So it means we have to look the probability for x less than 2 and yeah equal to all, okay. As we know, we always use this one. Use your calculator to find out the p value. So I think if you use it's 0.3 0.3028, right, which is greater than significance level, okay, which is greater than significance level. It means we will accept the we shall accept the h0, okay. So similarly you can apply this for the other word problem. I think you would have understood. Apply this concept for the other word problem. Test for next is the test for the product moment correlation coefficient, PMCC. Okay, we will do this test for hypothesis testing for PMCC. So if you have a set of bivariate data such as hours spent on homework by a student and his or her midterm grades, then it would be possible to show these on a scatter diagram and find their correlation R. This is unlikely to be the same value as correlation coefficient for the whole population, which is normally written as rho. But for a large sample size, it is likely to be quite simple. If you need a calculator to line up best fit for your data, that we know we use the GTC, right? And here null hypothesis will be rho equals to 0, okay? Rho equals to 0 will be null hypothesis. And alternative hypothesis, either rho is less than or greater than or is not equal to 0. So this is the fix here. I mean, null hypothesis is fixed. That is, yeah, this is rho equals to 0. And in case of alternative hypothesis, either less, greater, or not equal to, it will be mentioned in the question. But the null hypothesis is fixed. Okay. And so we will take some questions like this is, but we are totally dependent on calculator. These are the steps to do a hypothesis test for the population correlation coefficient. Perform the following steps. Write down the null hypothesis H0, right? Rho equals to 0. Decide on the alternative hypothesis, which will depend on whether you are looking for a positive correlation, negative correlation, or any linear relationships. Find and write down p-value. Compare p-value with the significance level of test and write conclusion. So earlier we were using, we were doing same things. We are comparing p-value with the right significance level. Here I will teach you how to find out p-value, because here you will have a number of data. So like question number 1, we discussed this. You can see we have this data, and we will I'll tell you how to perform this thing on your GTC. So I'm going to share GTC with you. So you can see your calculator on screen. So yeah, obviously start, when you will click on start, you will have this type of interface. So there is a test, T-E-S-T, test option here. So press F3. So for the PMCC, we will do T-test, okay? T-test. So you can see T is over here. Press F2. So there are 1 sample, 2 sample, and regression. We are doing this for regression, right? So you'll press F3, right? So have this option will have. So we need to write the values in list 1 and list 2. Okay. So I will go back, and first of all I will write this one data in list 1 and list 2. So I'm going to type the data in list 1 and list 2. So guys, as you can see, I have typed all the data in list 1 and list 2. Then I will press F3 for test, then T test, T, F2, then F3 regression. And we have, as you can see on your screen, this test we have to do for rho is not equals to 0, right? It's already written. So yeah, rho is not equals to 0. Yes, so it's already there. Execute. And you can see this, we have a T and P and degree of freedom, AB, all this, okay? But here we need to look only this P value. P value is 0.1033, 1033, okay? So we'll write this value. Now our test sheet. So as you can see, this in this question, P value we are getting for this part B, we are getting P value equals 0.1033, which is greater than 0.1 significance level. Okay, 0.1. Now we can see. So it means we shall accept null hypothesis hygiene. Similarly, you will perform this operation for rest of the parts. Now you know how to use this testing for the PMCC. So every time you have to fill this data in list 1 and list 2, this type of data, and then you have to perform t-test, right? So solve this exercise, and in each exercise, see there is a test, and there are only 3 questions in this exercise. I think you can do. If any problem, let me know.